Hello and welcome to College Algebra Semester Test Review. So number one, find the domain. Domain is all about looking for which x values you can't have. Here I have a quadratic with no restriction, so my domain is actually going to be all real numbers, or I guess it says an interval notation. We get from negative infinity to infinity. On this one, remember you can't square root a negative, so I know that x minus 5 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 5, because you just add 5 to both sides. So we would get bracket, because it's equal to 5 to infinity. Okay. And here, can't divide by 0, so I know that x minus 4 cannot equal 0. So we know that x cannot equal 4, therefore negative infinity to 4 union 4 to infinity. Because x can't equal 4, these have to be parentheses because we get every number below 4 and every number after 4. Where is it increasing and decreasing? Remember, we take these in terms of the x coordinates. So first thing I would do is I would plot my minimums and maximums because those are turning points. It's when the graph changes direction. So here I would say my maximum is the coordinate 0, 2, and my minimum is the coordinate 2, negative 2. Now, from here to here, my graph is going up. That would be from negative infinity to the x value of 0. Then my graph's going down. Again, x values from 0 to 2. And then my graph's going up again from 2 to infinity. Because I have multiple ranges in the same category, I have the union right there. Fog. So fog or f of g of x are the same thing. Whatever the second equation is listed, so in this case the g, it goes into the first equation. So I'm going to take this entire thing, x minus 4, and replace this x with it. So we get 3 times x minus 4 plus 1. Distribute the 3, 3x minus 12 plus 1. So we get 3x minus 11 would be our function. Now this one goes on to say, instead of having fog of x, it's fog of 2. This just means we're going to plug in 2 in for our x. So I'm going to get 3 times 2 minus 11. So 6 minus 11, so negative 5. Right? G of x such that transformation is being described. So remember that horizontal is inside and opposite of what you think it should be. Vertical is outside. So this is horizontal shift left 3 units. So left, I'm going to have to do x plus 3 on the inside. Because left goes to negative, we have to add 3. Vertical shift down 3 units. So that's going to be outside of the function. In this case, the function being the radical. So I get the square root of x minus 3 on the outside. Flexion across the y-axis. It's going to be in the inside function, multiplying by a negative. Vertical stretch by a factor of 2 at the outside. Shrink by a factor of 1/2, that's inside, and again, opposite. Okay. All right. Oops, sorry. solve. So let's distribute this and let's distribute the negative. So we get 7x minus 28 equals 1 minus x minus 9. Combine like terms, we get 7x minus 28 equals negative x minus 8. Add 28 to both sides. Add x to both sides. We get 8x equals 20. Divide by 8, divide by 8. We get x equals 2.5. Find the slope. Slope being, y2 minus y1 over x2 minus x1. So negative 8 minus negative 4 over negative 5 minus 2 plus, so I'm going to get negative 4 up top, negative 7, so we get positive 4/7 because negative divided by negative is a positive. Write the equation of a line that passes through the following points. So first thing we should do is find slope, so negative 6 minus 4 over 8 minus negative 2. We get negative 10 over 10. So that'd be negative 1 for my slope. Then I can use point slope form, this idea that y minus y1 equals mx minus x1. So I can pick either coordinate for the sake of argument and pick the first one. So we get y minus 4 equals negative 1, x plus 2. Distribute the negative 1. Y minus 4 equals negative x minus 2. Add 4, add 4. Y equals negative x plus 2. Okay. Number 9. Solve. So I can just factor what multiplies to 12, adds to negative 8. That'd be x minus 6, x minus 2. And I can set both of those equal to 0. Number 10, sketch the following quadratic polynomial. Label the axis of symmetry, vertex, and x-intercepts. X-intercepts I can do by factoring. So if you were to factor this, you would get, x plus 4, x plus 2. So then you can set both those equal to 0. So you get the coordinate negative 4, 0 and negative 2, 0. I'm sorry, positive 2, 0. This would be x minus 2. Okay. I need to label the vertex. So I would find the vertex. Easy way to find the vertex if you have both of these, it's always in the middle for x coordinates. So if I do negative 4 plus 2 divided by 2, we get the coordinate negative 1. So that's the x value of the vertex. So I can plug that into my equation, negative 1 squared plus 2 times negative 1 minus 8 gives me negative 9. So my vertex has to be negative 1, negative 9. Okay. And then my axis of symmetry would be the vertical plane right through it. So that'd be x equals negative 1 for my axis of symmetry. Okay. Answer the following questions about end behavior. Okay. End behavior for polynomials is pretty much defined by two things. We look at our leading coefficient and our degree. In this case, you see I have a negative leading coefficient and an odd degree. So I know that my arrows would be up and then down. Okay. Just looking at the extremes here, both those arrows are pointing up. Write a polynomial that has this end behavior. Well, they're both going the same direction, so that's going to be an even degree. and they're both going down, so that's got to be a negative leading coefficient. So anything that has a negative in front with an even numbered degree would be acceptable here. Sketch the following. I need a down arrow, then an up arrow. So literally anything in the middle would have been fine. Find all real zeros of the polynomial using algebra. State the multiplicity of each. So using calc, aka graph. Look for an x-intercept. So if I were to graph this and try to find an x-intercept, I would get a couple options. I'd get -6, I would get -3, and I would get 1. Now the interesting thing about the graph here is if I type in here quick, see x to the 4th plus 7x to the 3rd plus x squared minus 27x plus 18 graph is if I look at 1, it bounces. Because it bounces, I know it has an even multiplicity, aka this 0 has to happen 2 or 4 times. But also remember that the degree is the number of solutions that I have. So I actually know this happens a multiplicity of twice because I already have 2 other answers. Okay. Well, either way, let's do some synthetic division. So pick one of my zeros for the sake of argument and pick 1. And I can synthetically divide, rewrite all the coefficients. So 1, 7, 1, -27, 18. And synthetically divide, drop the first one. 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 9. 1 plus 9 is 10. Did I mess up somewhere already? Drop the 1. 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. Mr. Lane. 9. 1 times 9 is 9. -18. -18. 0. It works because I have a 0, but this is still not a quadratic. So this would be my remainder, my constant, my x squared, my x cubed. So I have to divide it again. I could pick -6, -3. This time I could pick 1 because it happens twice. Normally you wouldn't want to pick that same one, but I can pick 1 again here. So I'm going to reuse these numbers now because I'm not going to break down that any further. 1, 8, 9, -18. 1, 1, 9, 9, 18, 18, 0. So we have x squared plus 9x plus 18, which we need to factor. So x plus 3, x plus 6. So yeah, my other answers would be -3 and -6, along with the 2 answers we used along the way. So 1 with a multiplicity of 2, which is exactly what the graph showed. Determine whether it's a perfect factor. So you would just synthetic, and you need to get a remainder of 0. So for example, here, I would put -1 in the box. So I would do -1, 1, -8, 9, 38, and -40. Okay. This one doesn't work. And this one does. So be ready to just go through and do that synthetic division here. I'm going to spend more time on 14, solve the inequality. So here I want to get everything to one side, and here, because I have a quadratic, I'm in a factor. So what multiplies to -9 that adds to -8? That would be -9 and +1. So set both of those equal to 0. We would get +9 and -1. So I have to make an interval on the line, a number line with those numbers. And I have to pick a number in between each category. So for example, a number between -1 and 9 would be 0, a number bigger than 9 would be 10, and a number smaller than -1 would be something like -5. I then have to test it. I'm going to plug each of those numbers into this inequality. So -5 squared minus 8 times -5 minus 9. Is that less than 0? Well, if I were to plug that whole thing in, it is not less than 0. You end up with something higher than 0, so that's a false statement. I would then test the next one. So plug in 0. So I get 0 squared minus 8 times 0 minus 9. Is that less than 0? That is a true statement. So then I move on to the next one of 10. Is that less than 0? That is false. They will typically alternate, but they won't always alternate. So my last thing is I just have to write an interval from where it's true. Well, it's between -1 and 9. So I would say -1 to 9. Okay. Find the domain. Can't divide by 0, so x minus 3 cannot be 0. So -infinity to 3, union 3 to infinity, just like number 1. Here, can't be 0, so x minus 2, x plus 2. So if I were to simplify these, I'd get 2 and -2 that x cannot be. So it would look something like this. -infinity to -2, union, -2 to 2, union, 2 to infinity. And then this one's really interesting. If I did x squared plus 5 cannot equal 0, you would subtract 5 and then square root. So you would get x cannot equal the square root of -5. Well, the square root of -5 is an imaginary number. So this one actually has all real numbers. Vertical asymptote, it's kind of the same thing as when you would divide by 0. A hole in the graph is when you have something over something else and they cancel. So the first one, 5 minus x equals 0, we get that x equals 5 would be a vertical asymptote. X minus 4 equals 0, we get x equals 4 is a vertical asymptote. Here, I would factor this, so I would get x minus 2, but you notice I have x minus 2 up top as well. So these can be canceled. This x is by itself, so x equals 0 is a vertical asymptote. However, x minus 2 was canceled, so I know that x equals 2 is also an issue. That would be called a hole in the graph. Same idea here. Factor this difference of squares, so x plus 3, x minus 3. X plus 3 is canceled, so x minus 3 or x equals 3 would be a vertical asymptote, and x plus 3 equals 0 or x equals -3 would be a hole in the graph. Horizontal asymptote, there's 3 situations. First is if the degrees are equal, like here. So we just divide the coefficients, so 4 over 5. Second is if the degree is bigger in the top, you get no horizontal asymptote. Third is if the bigger degree is in the denominator, it's always y equals 0. Thank you for listening to the first half. I hope you have a wonderful day.